All right, lesson 14 is going to be on converting rational numbers to decimals. So fractions are basically mixed numbers, and we're going to use long division. Now, we already kind of used long division before. We're going to practice it some more. I'm going to give you some hints, and we're going to focus on the type of solutions we get. So let's quickly get started here. Can all rational numbers be written as decimals? It says using the division button on your calculator, explore various quotients. Remember, quotient is the solution to a division problem of integers 1 through 11. Record your fraction representations and their corresponding decimal representations in the space below. So I'm just going to kind of divide 1 by 2, 1 by 3, 1 by 4. Okay? And you'll see what I mean. All right, so I'm going to go 1 divided by 2. And I get 0.5. And then I'm going to do 1 divided by 3. And I'm going to get 0.333333. And then I'm going to go 1 divided by 4. 1/4, I'll tell you, is equal to 0.25. And if you don't know, type into a calculator. 1 divided by 5, 0.2, 0.2. Let's fit in here. 1 divided by 6. Now, I'm writing these as fractions, you guys, but remember, the fraction bar is the division bar. So when I write 1/6, 1 over 6, that actually means 1 divided by 6. And that's a 0.1, and then the 6's are repeating. Okay? And let's do 1 divided by 7. Oh boy. 142,857. 142,857. So it looks like we're going to go 142,857 dot dot dot. 1 divided by 8. 0.125. 0.125. 1/9. 0.1 repeating. 1/10. Well, 1/10, I know that's 0.1. And 1/11. Squeeze it down here. 0.090909. Okay. So what two types of decimals can you see? What do they mean by types? Well, 0.5, and then I have this 0.3 with these dots, meaning it's going to go on forever. And then I have 0.25 and 0.2, and then I have 0.1666666666 with all these dots. 0.142857, 142,857. Then this one just stops. This one's like 0.1 repeating. This stops. There's two types of decimals here. Okay, we have the terminating ones, and we'll identify those in a second. The terminating ones stop, cut off. And then we have the repeating ones. The repeating ones are we take a set of numbers and it keeps repeating. Okay, repeating is going to be non-terminating. It still happens. 1 divided by 9, that's still a rational number, it's still a fraction, but it converts into 0.1 repeating. Okay, so let's take these and kind of put them down here. So we're either going to have terminating. Oh, there goes a bad writing already. Or we have repeating. Terminating or repeating. So what are our terminating ones? Well, this one terminates. Terminating means it ends, it stops. So 1/2, which equals 0.5, that's a terminating decimal. 1/3, which equals 0.33333, that is a repeating decimal. Now, we all know how to use bar notation, okay? This is not notation. Don't do that. You take the least amount of digits that are repeating, and that's what you put the bar over. So don't just throw a bar over these. Rewrite it. 0.3, and just that 3 is repeating. So I only need to write the 1/3, because that's the one repeating. All right, 1/4, that comes over here in terminating because That stops at 0.25. 1/5 over here and terminating because that stops at 0.2. 1/6 though, that comes over here. This is 0.16 repeating. No, the least amount of digits possible, 0.16, and just put a line over that 6. All right, then we have 1/7. That's repeating. 0.142857. Now look at that whole thing's repeating. I'm putting a line over it. 1/8. That's 0.125. 1/9 is repeating. 0.1 repeating. So I'm just going to write it as 0.1 with the bar over the 1. 1/10, you get the idea. Okay, I'm running out of room here, but you know, we have 1/10, doesn't go there. 1/10 is 0.1, and 1/11 over here is 0.09. I put the bar over the 0 and the 9 because that's what's repeating. All right, so what do these fractions have in common? And we could do some research and we could figure it out, but I'm going to help us along here. If I look at these denominators here, okay, each denominator, okay, 2, 4, 5, 8, and 10. What I'm going to tell you about them is it is a product of only factors 2 and 5, which means if I could break these down, they're only going to break down into 2 and 5. Well, that's a 2. 4, guess what 4 breaks down to? 2 times 2. 5 breaks down to itself. 8 breaks down into 2 times 4. 4 breaks down into 2 times 2. Sorry, that one's hard to see. And this breaks down into 2 times 5. We'll practice that more. But what I want you to see is that when you do like a factor tree with these, they're always 2s and 5s. Where over here, each denominator contains at least, so 1, maybe more, at least one factor other than 2 or 5. Meaning, well, 3 is prime, 6 breaks down into 2 times 3, 7's prime, 9 breaks down into 3 times 3, 11 is prime. They aren't just made up of factors of 2s and 5s. That's going to be a hint. That's going to help us know if something is terminating or repeating, especially when we're using long division to figure it out.